In this video, I'll be going through the process of setting up the calculation option that will be used for unsteady state analysis. Before I can start setting up the calculation option for unsteady state analysis, I need to first activate Civil Storm. So that's going to be over at my Tools tab, and then I will click that icon to activate that license. Once that's been activated, I'm going to create a new calculation option and then rename it. Starting at the top, I'm going to first select my active numerical solver, and these are the options I have. And I'll be going with the explicit swim solvers. The implicit solver uses a 4-point implicit finite difference solver to find the numerical solutions for the hydrodynamic St. Venant equations. The solver is based on the National Weather Service model. The implicit solver tends to be more stable with pumping situations. The explicit solver, however, uses a solver from the EPA Stormwater Management Model version 5. The results from this solver should exactly match the results from SWIM 5. The explicit solver tends to be more stable with fast-changing areas such as ponds or control structures where the flow or elevation changes quickly over multiple time steps. If you'd like more detail on the differences between the different solvers, then I would go to Bentley Communities and search for this article, and it will go through and give different options as to when you should choose different types of solvers. Another thing to keep in mind is which runoff method are you trying to use. So we want to see what's supported for each solver. So in my case, I'm wanting to use the unit hydrograph runoff method, and I'm going to be choosing the explicit solver. And so that is going to be supported. Another thing to consider is what structure loss methods are supported for each solver. So I'm going to be using HEC 22 3rd edition, which is not supported by the implicit solver. However, it is supported by the explicit solver. The next few settings I'm going to skip past and leave the default, as these are settings that are going to be set per project to enter in the simulation start date and time and the reporting start date and time. For the duration type, we can either put in an end date and an end time, or choose user-defined duration, which you can type in the duration. So I'll use 24 hours here. Next, I'll enter in a routing time step, which is going to be the time step length used for routing flows through the conveyance system. For dynamic wave routing, a small step is normally required. For single event dynamic wave models, this time step is usually going to be just a few seconds. Between 1 and 20 seconds is common, and a minimum value of 0.1 should be used. The routing time steps should be smaller than the shortest time it takes for a wave to move through a conduit inside of the model. So I'll set that value to 5. Next, I'll put in the swim output increments, and I'd like to see that in minutes, so I'll change my units and formatting. And it's currently set to 15 minutes, which is just going to be the time interval for reporting the computed results. Next, I'll look at the minimum time of concentration. So if a computed time of concentration on a catchment is less than this value, this is the value that is going to be used. If you'd like to associate diurnal patterns with unit sanitary loads, then you can additionally set up a pattern setup. Here in the explicit results control, this is just choosing what degree you want the results to be generated for catchments. And these are your options. Same thing for nodes, links, and then the last one is if you want to include the average results for each routing time step.